Okay, well, good morning, Don. And the just to give people a sense of when we're recording, which is West Coast around 9:30 a.m. So, I'll for my students, I'll read the little Wikipedia um, that's on you, which is kind of interesting.
Okay.
Um, you know, Donald Hoffman is an American cognitive psychologist, and a popular science author, I suppose. Yeah. Um,
Well, that
um,
doesn't refer to me. That refers to the the popular doesn't refer to Hoffman.
well, I do think your stuff is eminently readable, which is probably and the way you explain yourself in general, and when we'll go into that, has been again so clear in terms of how you present very complicated ideas. And so
Oh,
that,
wonderful.
yeah, that is a gift to be able to do that. Not every philosopher, not every scientist is able to do it as eloquently as you. So again, appreciate it.
Yeah, thank you, Dave. Yeah.
And you're a professor, or I should say via Wikipedia, he is a professor in the Department of Cognitive Sciences at the University of California, Irvine. With this is interesting to me too. And as I got to know you a little better and read about you, joint appointments in the Department of Philosophy, Department of Logic and Philosophy of Science, and the School of Computer Science.
Right. I'm now emeritus, but yeah, when I wasn't emeritus, I had those joint appointments.
That's wonderful. So in any case, it's you are already interdisciplinary in within the field of cognitive psychology, but certain philosophy, and you have um you have all these other interests. And have you taught philosophy classes, by the way?
I taught a joint class with a wonderful professor of philosophy at UC Irvine, and it was joint. So Jeff, uh, it'll come to me, his last name. Jeff and I taught a class 20 years ago on philosophy of cognitive science and quantum mechanics.
That's great. Yeah. Well, and the way I would talk about what we're going to do today is years ago as well. I was editor of Columbia University's Graduate School of Architecture journal. It's called Précis. I actually don't know if they still publish it, but our journal, our edition, Précis 6. It's probably similar in many colleges. Different colleges inside these universities have their journals, et cetera. So that gave me and my two editors an opportunity to interview Jacques Derrida, Umberto Eco. I mean, major
Wonderful.
voices. And I think at the age of 22 or 23, it was difficult for me to realize how important folks like Jacques Derrida were to the history of philosophy,
Right,
and
right.
controversial too. And there are, there's been a huge reaction to what Derrida had brought to the world, which was this philosophy of deconstruction.
Hmm.
So through my own interest at Columbia University and Jacques Derrida, and there was a journalist for the New York Times who is now editor of Architecture Magazine, he's editor of architecture for New York Magazine, Joseph Giovannini. He brought deconstruction along with perhaps myself and a few others. We started to bring the philosophy of deconstruction into architecture, which definitely has seeped into the profession. And you could argue that, for argument's sake, Einstein may have been the first modern architect, using these
Okay,
very broad terminology.
okay.
So one of the things that we were fascinated by in the late 80s, which is when this journal came out, actually mid 80s, 1985, was the subject of interdisciplinarity. And this is, so my first few years as an architect, I was hand drafting And the coolest thing you could do then was to take ink pens and draw your construction documents in ink, you know. And then my first 2 years out, we're talking out of Columbia University, which would be, 86, 87, 88, was the dawn of AutoCAD.
Right. Uh-huh.
So architects, Don, we've always been looking into the world of computer science, fascinated with the software, can't wait to get our hands on it.
Right.
And some of the most complicated softwares in existence are used by architects, no question. I mean, whether it be Revit or AutoCAD, or so many others. The softwares are languages in and of themselves, as I'm sure you know. And so there has been this intense and increasing fascination with the digital world and the use of the limits of technology to produce works of architecture. But on a much grander level, a much deeper level, I think architects have been fascinated with, I think I mentioned this to you last time we talked in my class, this word I was taught, zeitgeist, the spirit of the times. And maybe it arises out of the Bauhaus in Germany, pre-war Germany. But it's this idea of what is the spirit of the times? And architects, one of the ways that I teach architecture to my students is that architects from the dawn of the profession, which if you want to call it a profession, sometime around the time of Plato and Aristotle, were trying to embody the pyramid, the top of the pyramid of thought into form. Now, to a certain extent, I know you've mentioned that your wife is an artist, but to a certain extent, art does this too, of course. I mean, all practitioners in kind of left brain activity in their own way are trying to find the limits, the way you have tried to find the limits in physics, et cetera.
Yes.
And so deconstruction came into architecture as a kind of built chaos, an attempt to kind of understand and build chaos. And it's produced some phenomenal spaces. I mean, one has to look into the work of Daniel Libeskind, perhaps, or Zaha Hadid to a certain extent. And so that's one component. And then there have been other components of the profession that have tried to look beyond classical language, which is bilateral symmetries and classical orders, base, middle, tops, and this is for better or for worse.
Okay.
And as Frank Lloyd Wright, well, actually, as Paul Simon wrote about Frank Lloyd Wright, architects may come and architects may go and never change your point of view. So, but I do think that at the limits of the profession, there's a yearning and a real interest in trying to understand the other disciplines.
Okay.
So before I go into some of the questions that I've already sent you and that I could use as ways that we can extend the conversation. I lost my train of thought. So let's start. I'll come back to this. So maybe I will start with the first questions. So one of the and let's just see here. I have a couple statements here before we start. So I said that I'm interested in interdisciplinarity. And this podcast is really rooted in that I want to try to talk to as many experts from other disciplines to try to enrich how architects think about our philosophy of how we proceed and design in our work. To go right to what you have been studying, what that would mean ultimately is, for instance, I'm interested in an architecture outside of SpaceTime. What does that look like, if it's possible?
Right.
Yeah, and then there in my recent studies, and you've been part of my appreciation of these recent studies, there appear to be many different theories and a lot of work being done to consider what is projecting space-time, or better yet, what space-time is projected from a deeper complexity. So what I realized is that, and you've said this, I mean, it's not you alone that has discovered that there may be something outside space-time. It's
not by a long shot.
and it's happening in the wider field, and there are different approaches as to what it might be. So, and some general thoughts that I had here that I jotted down last night. In order to know the quantum and the infinite, we must certainly know the local. Architecture may be one of the experiments in the local to try to know the infinite. In terms of this kind of language of what can we have a local, and do we have a local? And I believe absolutely there's a local, me and you talking right now, picking up your iPhone or whatever, and then our ability to imagine the infinite or the non-local, let's say. And again, forgive my clumsiness in speaking about these issues, but I'm certainly curious about it. So there appears to be a collapse in our knowledge, which is ongoing, which is a result of our increasing knowledge. That collapse is that everything is numbers, perhaps. Everything is consciousness, and therefore everything is knowable by the other thing. And so what I'm suggesting there is that the more we seem to know, the more the danger is a kind of I'm thinking of like Michel Foucault. There's almost and to a certain extent Jacques Derrida way back when, is that there's a kind of madness in the more we know, and it's very destabilized. And the more we shed our surface understandings of the religions and of our what our parents taught us about God, what our ministers or might have taught us, it becomes deeply frightening to let go of all the reins. And again, I think by way of my appreciation of your work is you're doing that, and you're actually trying to back it up with science.
Right.
Okay, so I'll start with the first question here. I said, is there some kind of architecture at outside of space-time that could be measured?
Yes, and what's remarkable is that the physicists are pioneering the discovery and the understanding of that realm. There's a whole new branch of physics in high energy theoretical physics. So it's the high energy theoretical physicists. So it's a very, very special branch of theoretical physics. And what they've got now is what they call the study of positive geometries. So it's a very, very much architectural sounding. In the positive, it's called positive geometries beyond space-time. And there was just in Europe, there's a big grant, 10 million euros just given to set up a center for the study of these positive geometries beyond space-time, because it's now the initial results are so promising that they realize this is an important direction forward. And so Europe is going in big time on this. That includes American American-based physicists are involved in that whole thing. And by positive geometries, they mean it's something technical, but it means roughly objects that you can give a geometric description in terms of volumes and so forth of. There are many mathematical objects that you can't, for example, talk about their volumes and so forth. It might be just perfectly infinite or something like that. but and also, I mean, it's a technical thing. It has to do with whether certain parts of the geometry have like positive values, something called the minors of the geometry. But if you think about polytopes, like a tetrahedron or some kind of polytope, those are examples of positive geometries. And what they're finding is that when they let go of space-time, say space-time is not fundamental, right? We thought it was fundamental, but it's not. And we need to find these new structures entirely outside of space-time that will allow us to overcome the limits of space-time. Space-time falls apart at 10 to the minus 33 centimeters, 10 to the minus 43 seconds, the so-called Planck scale. It ceases to have any operational meaning. And that's why, well, it's one of the major reasons why physicists are saying we need to, I mean, our math is telling us we have to go beyond space-time. We have to look for new structures. And hopefully, I would say new dynamics. Now, they themselves have not found dynamical systems outside of space-time. Well, right now they're just finding these positive geometries. So they're finding architecture, so to speak, outside of space-time, but not, you know, in physics, typically behind any structure, you'd like to find a dynamics, which is giving rise to that structure. Like, you know, for example, the structure of an atom inside space-time. Well, we have, you know, the equations of quantum theory, which are describing stochastic processes that are sort of underlying what we think of as the stable structure of the atom. So you would like to imagine that when we go outside of space-time, we could have something like that found there as well. Some kind of dynamical process, maybe a probabilistic process outside of space-time that somehow gets summarized by the positive geometries that the physicists are finding. But they haven't gone there yet. So they're just right now uncovering these amazing positive geometries. And I would say it's only been in the last 10 years. So I mean, one of the first ones to really be discovered was the amplituhedron, and the publication. I mean, I think it was an archive paper was put out in 2013, but you know the publication was 2014. So it's been 10 years since an official publication really sort of launching this positive geometry success story. So this is all brand new stuff, and it's exciting enough that you know, big money is starting to be poured into it now. After 10 years, they're realizing that wasn't a one-off. That paper wasn't just, you know, just some weird thing that the guys got lucky. It seemed to be the tip of an iceberg, and we need to find out what that iceberg is and study it quite deeply. So that's pretty exciting. What I'm doing is a theory of consciousness, where for other reasons I've been starting outside of space-time. Partly because the reductionist approaches that I've tried and my colleagues have tried to boot up consciousness from inside space-time have failed miserably. They just don't work. We've been at this for decades, and there's not one theory that starts with, say, neurons inside space-time or physical systems inside space-time and can explain even one specific conscious experience. Not one. And these are my brilliant friends and colleagues. They're not dumb. Many of them are geniuses. They're not failing because they're dumb. They're brilliant. They're failing because you can't do it inside space. And so our field is finding out by putting geniuses on the task and having them fail that you can't boot up consciousness from inside space-time. So I, you know, I'm no genius. So I just decided if the geniuses can't do it inside space-time, why in the world am I trying? Let me get outside of space-time. Maybe I'll have a shot. And so I'm working on a theory of consciousness outside space-time. And what I'm doing right now is with my colleagues, Chetan Prakash and Swapun Chattopadhyay and others, we're working on showing, if we can, how these positive geometries can arise from a dynamics of conscious agents outside of space-time. So that's my goal right now, is to show that the architecture outside of space-time can be described as sort of describing the long-term behavior of the interactions of conscious agents outside of space-time. But regardless of whether we succeed or not, physicists, I would think, are going to want to have some kind of dynamical systems outside of space-time. But I don't think that they'll be satisfied with just static structures, right? They're going to want to say what dynamics gave rise to those static structures. And as soon as you do that, you've got this very interesting question, which is, so we have dynamical entities outside of space-time. What are the natures of these dynamical entities outside of space-time? What are we talking about? What does it mean to be a dynamical entity outside of space-time? So we're going to have to face that, right? We know about entities inside space-time. What do we mean by entities outside of space-time that are interacting in the dynamics? So that's going to be, I mean, I think that's a question that's going to face us as scientists, and will face the physicists. Right now, you don't have to face it when you're just dealing with the architecture, right? You still have a question, which is, okay, who ordered this architecture? What is it doing out there, and why? Why, so if space-time is like a VR headset, and we're for the first time as a species taking off this VR headset and looking around outside of the space-time headset, and we're finding these geometric objects like the amplitude, the positive geometries. So there's a bunch of positive geometries: the amplitude-hedron, associahedron, cosmological polytopes. There's a number of these buzzwords for these positive geometries. But the big question then is, okay, well, great, we found these things and they work. They allow us to describe like particle interactions at the Large Hadron Collider, scattering processes. We can actually predict the scattering amplitudes from the volumes of these architectural objects outside of space-time. So that's truly amazing, and for that reason alone, it's great because it simplifies the computation. It shows us that we don't have to do it inside space-time. In some sense, space-time is just the wrong framework. It actually is a kludge. It makes the computations more difficult, and it also hides symmetries that once you let go of space-time, you start to see new symmetries that are true. So the architecture itself embodies symmetries that you can't see inside space-time, the architecture outside space-time. So we're already being led by this architecture to say, okay, why are we seeing these new symmetries in the architecture that we couldn't see inside space-time? Why is it making the math so much simpler inside space-time? Who ordered this and why? And there are no answers. So this is exciting stuff, right? This is really, really fun stuff. And in our work on conscious agents, which is a stochastic dynamical system of interacting, it's like the Twitterverse, right? You think about a big social network with agents tweeting and following and so forth. That's sort of not far from the idea that we have here, is that there's a vast social network outside of space-time of conscious agents. And the long-term trends and how they interact is giving rise to this architecture, the positive geometries that the physicists are finding. So
yeah,
that would be fun.
Yeah. And I could probably just let you expound for an hour and not say a word, but I'll try to interject here and there.
Sure.
So, one of the things that I started to cover with you in my class when you joined my introduction to architecture class, one could argue that there's probably no more materialistic a profession than the profession that I've spent my life doing, and I'm a practicing architect. So, if you separate it out, for argument's sake, from the infinite musings of philosophers and physicists, you have a hammer, you have a nail, you have a bunch of lumber, and as we get into this, on the surface, for instance, if you miss the nail, you're going to hit your thumb and it hurts like the dickens. And if you're sawing and you're not careful, God forbid, you're going to have some serious injury. Certainly worldwide, there's now a globalization of both highly reproduced components that we use to create buildings. And as I said, at the limits of architecture, there are now a unification with car manufacturer and robotics to allow for three-dimensional curved spaces, and there's all sorts of movements away from the more rectilinear 24-inch on center or 18-inch on center wood studs that we make our homes with, et cetera. So again, architecture is immensely, certainly on the surface, immensely tied to the material. So I'm probably misquoting, but I think it was from one of the great architects, Le Corbusier, someone of that order, that architecture is ultimately the most tragic of professions because everything turns to sand. And even the pyramids, given perhaps not 3,000 years, maybe it'll take 1,000,000 years, who knows? But eventually, as the earth burns in the fires of a dying sun, everything disappears.
Right.
What's remarkable about the current work and what just made me smile when I was listening to, when I was first introduced to you through, I think I mentioned Lex Friedman's podcast and numerous others, but I think a number of years ago when I first heard you speak, is the idea that no, that's not true, that at the base it's consciousness, it's not materialism. And then, you know, I've heard beautiful reinforcements from Bernardo Kastrup, for instance,
Right.
some, you know, so different components and in this spectrum of this idea of consciousness at the root.
Right.
So remarkably, again, one of the things that's happened in architecture is aligned with video games and is aligned with virtual reality, is that a lot of architects are almost certainly working in the video game industry. So we're producing worlds. Architects are now producing worlds virtually where we could do anything. Buildings can fly, you know.
Cool.
So I do think from my work in virtual reality, because I'm also a, you know, a renderer, I teach rendering and all this business. How could one not think that anything's possible? That what's possible inside that world is possible in this world that we call the material world. But it keeps collapsing back, Don, to the fact that this is I don't know if I want to call it dreamlike. Some people would, but that our headset is to allow us to communicate to each other. That however you want to talk about the Don Hoffman headset theory, we are making agreements, and this starts to align with Michel Foucault's ideas of madness and civilization again, and with deconstruction and all sorts of continuing philosophies. We make agreements to make sense to each other, but it's within this kind of conscious field. And I think we are at a critical moment where here's another way to say it. Just like you, I mean, we're almost the same age. You and I both saw computers, you know, arise out of the ether.
Right.
And you were probably certainly coding with disk operating system before there was Windows, just like me. I was clicking away on you know, before the Windows interface. That's how old I am, right? Is that
Well, yeah, I was using punch cards.
my dad? I was using punch cards too. Yeah, that's
Yeah,
right.
I used
Right,
punch cards
right.
back. I was programming back in 1973, 74,
Amazing. Yeah.
using punch cards. And 1976 through 70, I started working at Hughes Aircraft, and on a military microprocessor called the Anyuk 30. And we were essentially coding the machine code. And in 1978, I and 3 or 4 other programmers delivered a full flight simulator to Wright-Patterson Air Force Base. It took 64K because we basically programmed the ones and zeros in machine code. So we were able to write, you can't even send an email in 64K today. I mean, but we did an entire flight simulator in 64K because we were doing it in the machine code of this this military microprocessor.
Yeah, it's amazing.
Yeah, so it's been, yeah. So I watched it go, and actually I'm good friends with Federico Fagin. He was the genius who in the late 60s invented the microprocessor at Intel. He was the guy at Intel that put it together. And so it was great fun to meet the man who just a couple of years earlier had built the machine that I then was programming at Hughes Aircraft.
Well, so certainly one of the things that has changed, I think, and perhaps fundamentally, epically, historically, is that everything, every possible discipline is in some way relying on the digital world.
Right.
And that may be the key to interdisciplinarity. And yet at the root of that, what it's hinting at is what I think you can tell me, but I would have thought, I was listening to you. It was more of a talk because you're a very polite human being, but you were talking with Tom Campbell, the
Yes.
physicist and philosopher. He's a lot more tied in, I think, to pure virtual reality. That the whole thing is, and I think there's some slight differences in the degree to which you hold the real world, some notion of the real world. I don't think he does. So, but it is that digital realm that is ultimately evening everything out, and that is potentially allowing folks like you to dive into this idea that it is, if there's any connection at all, it's that consciousness is at the root. But I think as we go on in time, you can tell me how you feel about this. There appears to be a unification of disciplines. Everyone's searching for the same thing at the limits. That's what it feels like to me. That each of us in our different disciplines are searching for the same kind of answer. And we could go back, we could get as cosmic as we want on this, but the religions were the first ones. Here's another way of talking about it.
Okay.
In my humble opinion, I think the religions were our first attempts at human beings really wanting to live forever. That there's some component in us that wants to beat this definitive end that we seem to be facing. I've heard you speak very eloquently. It depends on which interviewer is prodding you about the ultimate consciousness, and that there may be some super consciousness that is at the bottom of the turtles.
Right.
And that we are simply we're each individuated conscious entities that are experiments for the larger consciousness. And to the extent that we can prove that in terms of physics and science is inspiring and wonderful. But the other thing that I love about the way you present your work is that you believe there's no answer, that there is no bottom, and that there's going to be tons of work cut out for the physicists and the scientists. And I think there's tons of work for all of us, and I don't think there's any answer.
I agree. Yeah, that's correct. And the argument for that is fairly simple from a scientific point of view, right? You hear about scientists saying we're close to a theory of everything,
Right.
And what is a scientific theory? Well, the scientific theory at its stripped down to its basics says, please grant me these assumptions. If you grant me these assumptions, then I can explain all this other wonderful stuff. So a theory only works if you grant it its assumptions. And if you don't grant the assumptions, it can't explain anything. So, and what it doesn't do is explain its assumptions. It assumes its assumptions. So you might say, well, I can give you a new theory which explains those assumptions of the prior theory, and that's true, but your new theory will have its own assumptions. And this goes on ad infinitum. So my take on it is that first, we need to do science. It's one of the best exercises of human intellect. It's fantastic. So I love science. I'm not putting down science in any form at all. But on the other hand, I'll say this: science, even if it goes successfully for trillions of years, will not even begin to scratch the surface of the depths of reality. It will effectively have gotten probability zero into the depths of reality. And so whatever the reality is infinitely deep. And no matter how long, trillions of years we spend studying it, trillion compared to infinity is nothing. in terms of how far we've gotten. So we should do science. We should do all the various kinds of intellectual adventures that humans do. I think that's my guess is that that's part of what consciousness is up to, is exploring its potential, and that exploration is infinite. It's unbounded, which means that there's no end to the fun ahead in terms of the exploration. We'll never say, oh, that's it, and wow, here's the book. That it's all in the book. There's nothing else to say. No, not at all. The exploration will be infinite, and the exploration, I think, is ultimately exploring, who am I? Who are you? We are not separate from that infinite. We are that infinite, exploring its potential. So this has a completely different point of view of what a human being is from a physicalist view. So a physicalist view says, I'm about 160, 170 pounds of matter inside space-time, and very, very brief life, and consciousness somehow arises from complex interactions of, say, neurons in that matter. And during that brief time, that complex interaction of neurons leads to these feelings of, I want to be something more than just this 160 pounds of stuff, and I want to live forever, and so forth. That whole framework I'm saying is wrong. That space-time is not fundamental, and I'm not a little chunk of matter inside space-time. Nobody is. Instead, space-time is a little data structure inside you, inside me. So we are a consciousness that happens right now to be looking at itself through a little VR headset that we call space-time. And effectively, it's the infinite consciousness choosing to put on a little avatar in a particular virtual reality and explore this aspect of itself. Here's a projection of my possibilities into space-time, and let me explore that for a while. And then when I'm done, I'll take that headset off and try another one, maybe a much more interesting one. 4 dimensions, 3 of space and 1 of time, and falling apart at 10 to the minus 33 centimeters, which our current space-time headset falls apart then. It's one of the cheaper headsets that we could try on. It's not a really fancy headset. So I'm sure that we'll be off to much more interesting headsets with many, many more dimensions and far more depth.
Well, to
So
talk,
it's
oh,
all,
sorry, yeah, to
just one
talk
last
about
thing. Yeah, go
to
ahead.
talk about the 10 to the minus 33. What I've read about that is that in order to actually look in that space, you need some hadron collider that was as big as our solar system. That the amounts of energy are not possible to reach to be able to examine something in that space. Because at that level of density, everything falls into a black hole. I mean, what could you describe that a little bit as to why we can't why we can't see into there?
Yes, it's an interesting implication of Einstein's work and some results from quantum theory. So what we discover is that if you want to look at something at a smaller and smaller resolution, finer and finer resolution, it makes intuitive sense that you're going to need to use like light with smaller and smaller wavelengths. If the wavelengths are too crude, you won't be able to resolve what you're looking at. So you need to have wavelengths of light that are small to resolve small things, and that's fine. We know how to make light with higher and higher frequency and smaller and smaller wavelengths. But what Einstein taught us in 1905 was that when you do that, the energy is going to go up. So Einstein taught us in 1905 that E equals h nu, and the energy is going to, as you get a smaller wavelength, your energy is going up.
Right.
But then he also taught us in 1905 that energy equals mass. So effectively, there's the masses going up as well. So he taught us two incredible things. And then in 1915, with his general theory of relativity, he taught us that mass curves space-time. And he published that, and then Schwarzschild, within a year or so, a German soldier actually, but obviously a brilliant guy, looked at Einstein's equations and realized that they proved that they create, in some cases, they create black holes. When you have so much mass in a small region of space, you create black holes. And Einstein didn't recognize that. So that was news to him and he didn't like it. So what the bottom line then is this: as you try to look at things at a smaller and smaller scale, the energy in the light is going up, which means the mass is going up. And at some point, the density of the mass energy of the light is so high that you literally destroy space-time in that area. You create a black hole. So you destroy the very object that you're trying to look at. And when does that happen? It happens that when you try to probe at 10 to the minus 33 centimeters, which is a distance that takes about 10 to the minus 43 seconds to traverse at the speed of light. So what Einstein's theory, together with Einstein's his theory of space-time, together with his theory of the photoelectric effect, tells us basically that space-time has no operational meaning at 10 to the minus 30, at the Planck scale, 10 to the minus 33 centimeters, 10 to the minus 43 seconds. It's that it basically just falls apart. And it's not 10 to the minus 33 trillion centimeters. It's just 10 to the minus 33 centimeters that it falls apart. That's why I say it's a very shallow data structure. Now, what the point you made is an important point, that right now our technology is nowhere near close enough to create those kinds of energies. But the universe does have those kinds of energies. There are black holes all over the place, right? There's a massive black hole right in the center of our galaxy. So these things are not just theoretical fantasies. These are, we're actually, in the last few years, we've gotten pictures of black holes now. So they're out there. Space-time falls apart. So we know that that's the case. And so that's what's forced physicists, like these high energy theoretical physicists, to say, okay, our mathematics of space-time is telling us that space-time can't be it. And by the way, that's the way science works. A good scientific theory will tell you the scope and the limits of that theory. Not only the scope, but also the limits of that theory. So the mathematics done right will not only say how good the theory is and what it can do for you, it will also tell you where the theory stops and where it can't go any further. And that's what Einstein's theory tells us. It tells us it's a great theory, but when you get to 10 to the minus 33 centimeters, it's game over. That theory has nothing intelligent to say anymore. And if you want to have something intelligent to say, you need a new framework. And the new framework is not going to be space-time. And that's what, in the last 10 years, where the physicists, the high energy theoretical physicists who are studying these positive geometries, they're realizing, wow, there's this whole new world entirely outside of space-time. And so the younger generation is jumping in and finding all sorts of stuff. And this is actually a lesson for us. We should never be resting on our laurels.
No.
And saying we're there. We have the theory. We're close to the theory of everything. Our attitude should be this: I don't know diddly. Humility is really the fundamental attitude that's the most intelligent attitude in all of this. To look at all of our scientific theories and just know that in a century, everything that we're looking at and so proud of will look like the simple past compared to the new stuff that has been found in the following century. And so just recognize that everything that we're doing will be transcended by the next generation.
Yeah, I wanted to reinforce how appreciative I am of your humility as an eminent scientist and the way you present yourself, because too often, podcast or not, you often find scientists who are outrageously confident, let's say. And to talk about that for a minute. So, in essence, according in Don Hoffman's theoretical framework, the door closes. The door is closed at 10 to the minus 33.
For space-time.
And so your curiosity, which I do think is fundamental to the human condition. It's arguably the best part of the human condition. So your curiosity is what's behind the door. I want to go behind the door. And exactly. so people look this way, look that way. You're absolutely not the only one doing this, thankfully.
Right.
And things are getting remarkably, things apparently are getting discovered. Could you talk about the Nobel, just for a minute, the Nobel Prize that seemed to reinforce some of your theories that just occurred a couple years back?
Right, yeah. So in 2022,
Mm-hmm.
the Nobel Prize in Physics was given to Alan Aspect, um, uh, Zeilinger, and John Clauser, those three, for experimental verification of an interesting prediction of quantum theory. And that is that um, the prediction is that what we call local realism is false. So local realism is something that most of us deeply believe, and that is, if I look at a rock, I see where it is, I see its position, I see its size, and I can tell you what its mass is. And it's natural for me to assume that even when I'm not looking, the rock still has that same position and that same mass and the same, if it's moving, the same velocity. So in other words, when I look, I'm seeing the true parameters, the true physical properties of that object that were there even if I didn't look. That's our normal intuition.
When you look at the Guggenheim Museum in New York City, you're looking at the Guggenheim Museum. It's there.
That's right. And the Guggenheim is there even if I don't look. If no one looked, right. So it's the old, is if a tree falls in the forest and no one's there to look, does it make a sound? That's the question right here. That's the philosophical question. So, well, quantum mechanics, it's straightforward. Well, if you know quantum mechanics, right? Quantum mechanics is not straightforward for anybody. It's tricky, but within quantum mechanics, you can set up systems of particles and measurements where you can prove two interesting things. You can prove that there are a certain set of measurements you can make, and you can prove that you will get a certain outcome with probability 1. So you can say that I know that when I do this set of measurements, with this measurement, I will get a certain value with probability 1. But you can also prove from the mathematics that that value could not possibly have existed until you made the measurement. Okay, so that's truly remarkable. So the mathematics of quantum mechanics allows you to set up physical scenarios, systems of particles and so forth, where with probability 1 what the outcome will be, and with certainty, the mathematics is absolutely certain that it couldn't possibly have existed until you made the measurement. So that's just a flat out refutation of local realism. So there are systems where there's no ambiguity. Local realism is just flat out wrong, and the idea is that it's just flat out wrong all the time. Basically, it's not just in the systems where we can actually make a logical contradiction that we show is not, that local realism is just false all the time. And so that's my interpretation of the Nobel Prize, is that it was for experimental verification. And they talk about it the same way, that local realism is false. Now, there are some physicists, I think, like Sabine Hossenfelder, who are arguing that superdeterminism might somehow rescue certain cases of local realism. But that's why I led off with the example where I said that there are specific cases where superdeterminism will not save you. It cannot save you, because we can prove that by the structure of the setup that the value didn't exist.
You want to talk about superdeterminism for a second? You want to take on Sabina's?
Well, she's formidable. Superdeterminism is, as she points out, is sort of a misleading term. It really has to do with correlations, non-standard, non-local correlations, effectively. So that's sort of a technical thing. So I would just put it this way, that most physicists now think that local realism is just plain false. Some don't. I think Sabine Hossenfelder, but that there may be cases where local realism isn't false. But Chris Fuchs, for example, and others have published examples where in this particular example, nothing can save you. Local realism is absolutely false in these examples. And so given that we find some systems for which local realism is false on anybody's account, I think it's in the cards that it's just plain false.
Well, if I understood the theory correctly, I heard recently that local the localism is our way in, obviously, to discovering the non-local. So the interface is the local, in a sense. I mean, in order for us to communicate at all, there has to be an agreement that I'm speaking to you on a screen and we're on Zoom. And if if the non-local is another way to say it, this was a reversal. And again, architecture, we get to misread everybody.
Yeah.
So I listened to, I don't know if you've debated Tim Modlin, if you've,
we had a friendly conversation. I don't think it was a debate. It was a friendly conversation.
Yeah. But probably my misunderstanding of one of the many things that he's spoken about is this thought that we're in non-Euclidean space, that our reality is non-Euclidean, and that this outside space-time idea is actually Euclidean and probably one-dimensional. And there is no space outside space-time. So it's flatland in a sense. And as I made an attempt to understand what some of Modlin's work, he also talks about foliation and layers of space-time inside our space-time. And architecture, as we try to imagine geometries, and we try to imagine new geometries, and architects try to imagine space that has never been seen. This idea of kind of capturing moments of Euclidean geometry, and opening our minds to, it's almost like architects are attempting this measurement problem at any moment. We are trying to freeze time. I think that at the limit, if we had a round table, and then maybe that is something, if my podcast succeeds here and I get a round table of leading architects and numerous inspiring and wonderful physicists like yourself, or scientists like yourself, you would probably get some concurrence in that we're trying to move the conception of space forward. And so thinking of my naive understanding of some of the things that I've heard Tim Modlin speak about, would be trying to capture that in our chaotic world, trying to capture some notion of what is outside space-time. It's that type of thinking.
Right. So yeah, when we say that space-time is not Euclidean, it's Einstein taught us that in his general theory of relativity. And also in special relativity. Even in special relativity, it's you have a hyperbolic space. It's not a Euclidean space. So even when you don't bring in gravity, you have a hyperbolic space. But then when you get into general relativity, it's you get these Riemannian manifolds. So it's really now. And locality in this context means that nothing can communicate faster than the speed of light. No influence can propagate faster than the speed of light through space-time. That's what is technically meant by locality. And realism means that objects is the claim that objects have definite values of position and momentum and spin even when they're not observed. And so to say local realism is false is to say that no, they don't have definite values of position, momentum, and spin when they're not observed. They only have those values when you observe. And quantum theory allows for entanglement, so which is a non-local connection, but it doesn't allow you to transfer information faster than the speed of light. So there's a sense in which even quantum theory doesn't violate locality. But when we go beyond space-time for these new positive geometries that the physicists are finding, what they're finding, and this is an important point, they're not finding a new master geometry outside of space-time that sort of is a replacement for space-time. So there's not some kind of new space-time version 2 that they're coming up with. They don't know what the global geometry outside of space-time is. What they're finding is just specific architectural objects. We don't know where what space those objects reside in. This is an interesting situation, right? So inside space-time, we sort of have this framework, and we can put architectural objects inside the framework of space-time.
Literally.
Now we're letting go of space-time, and we're finding architectural objects outside there, like the amplituhedron and associahedron. So these are nice little architectural objects outside of space-time, but we don't have a meta space-time in which they're fit. We don't have this, like, what is the headset outside of our headset that in which they're fit? So no one has that. Now, what I'm proposing is that there isn't any such, that there's just a network of a social network of consciousness entirely outside of any geometry. That network has its own internal geometry, but it's not embedded in some larger geometry. So the network of conscious interactions is itself, in this framework, the final answer, right? Now, of course, that's the final answer in this theory. Now, as I said earlier, this is not even a scratch on the surface of reality. And the nice thing about the mathematics of our theory is that it tells us that even in the context of just consciousness, what we can do with our current mathematics is trivial compared to what is to be done. So the mathematics that we have right now lets us know that what we've got is fine. We can work with it, but there are questions that we would like to answer that cannot be done in the current mathematics. So our mathematics of consciousness already tells us strong limits on our current theory that we'll want to try to transcend. But right now, I'm just busy trying to put this theory together before we transcend it.
Okay, so let's there's a couple different areas I wanted to talk about briefly. First, to further define, and again, this could arise with my misunderstandings, and I'm sure you'll clear some of this up. One way that I'm understanding the reality of all this at the quantum level, let's say, and Dave's understanding of the quantum, is that at the very root of it all, perhaps after in the space-time that we're in, after everything dissipates, assuming entropy is working just fine in our reality, eventually we're going to end up with something called photons, and the photons have no mass, and or if we look at the quantum level at electrons and protons and then quarks and gluons and all the rest of this, eventually at the smallest possible component that we are able to view in our reality as human beings, there's no mass, there's no there. And perhaps one way of talking about it is that we're constructed of light, that we are compressed light, and that would reinforce that consciousness is at the root. Is that if that is if I'm correct in what I just understood or have attempted to understand, then what gives us the weight of things? What is it obviously, again, if everything is if at the root of all this is consciousness, then that there really is no mass in that kind of conclusion.
Right. So in current physics, there are two particles that are completely massless: the photon and the gluon, and they're both bosons. They're spin one particles. All spin half particles have mass. Some very little, like the neutrinos, have very, very little mass, but the electron and proton and neutron. But you're right, when you look inside the proton, and it's composed primarily of quarks, which are spin half particles, and gluons, which are the massless spin one particles. And when you look at the mass of the quarks inside of a proton compared to the mass of the proton, it turns out that the mass of the quarks inside the proton are a very, very small fraction, just a few percent of the mass of the whole proton. And so the question, well, where did the other mass come from? Well, it comes from, as it turns out, the energy of the gluons. So the gluons are massless, but they have energy. And Einstein told us that E equals mc squared. So energy and mass are convertible. And so most of the mass of the proton is actually due to the energy of the massless gluons that are binding together the quarks inside the proton. So it's a really, so what's going on inside of a proton is really complicated. There are these quarks, but these gluons are moving at the speed of light. Okay, they're inside of a tiny. So this is a hectic place. We're seeing these massless gluons. If you're massless, you have to move at the speed of light. So they're moving so quickly, they have so much energy that they're 90+% of the mass that we perceive of as the mass of the proton is actually just the energy of the massless gluons binding these different quarks. So you can see it's complicated. It's not a trivial thing. Ultimately, mass is one of the interesting problems in physics. They have to put the mass in by hand. Their mass is not predicted in most cases by you have to actually, the Higgs boson is was famously discovered in 2013 or something like that or 2012 or just over a decade ago. Yeah. It's CERN. It had been predicted by Peter Higgs and others. And my understanding is that it's sort of an add-on that the Higgs mechanism for creating mass creates part of the mass. But I think that physicists themselves think that there's still a lot more to the story that they don't understand about the creation of mass. But the Higgs mechanism, of course, is a central part of what we do understand about that mass creation process. But I think that mass is a place where I would say physicists would say, yeah, we have a lot more work to do to understand mass because, for example, we have to put in the mass by hand in most cases. That's an empirical number. We don't predict it. And we have a mechanism for some mass generation, but I think that I think most of so I agree with you in the sense that the notion of mass is still problematic. The Higgs boson was a big leap forward, no doubt about it. But there are hints that there are new discoveries ahead.
Okay, so that it's very easy for an architect to say that we have, if you look at the history of architecture, let me it's let's say by the way, just for comfort, let's say we close at about 20 minutes. Is that
sure?
Yeah. So if you look at the evolution of the history of architecture, this is a good one. Is that human beings at some point, probably pre-human, slightly pre-human, we were because they know that apes were living in nests. They can create nests in trees, etc. So the first explorers that might have been humanoid or human were hunter-gatherers, and we had very light structures, tents, teepees, the rest of it. And they now, I think Jared Diamond wrote about this. The first towns were not created for agriculture. Agriculture came after the first towns. The first towns started to be created when early human, looked up to the stars, and something changed in us, the cognitive revolution, etc. And we looked up to the stars, and we started to wonder, what in the world is going on? Something happened. Now, there's
Right.
some argument that Yuval Harari wrote about it very eloquently in *Sapiens*, that it was fire, and we could create fire, and we could kind of stop a little bit, and our brains started to change because we found a way of protecting ourselves against being eaten. So the first architecture were blocks of stone that the early peoples felt they needed to pray to the gods. So
Okay.
that preceded agriculture. There are good theories, and I'm convinced by some of the writing that I've read on this, that it was our innate desire to know the infinite that created the first architecture. So the first architectures are very massive, the first real architectures. And of course, the biggest example is the pyramids. And pyramid building was universal. So we were a very globalized species, probably before human beings. They have some archaeological records that seem to indicate that primates also got on rafts to find foods in other areas. So globalization appears to be part of what has created us. But as time has gone on in architecture, I do believe that we've been trying to get lighter and lighter and lighter. Architects are trying to dematerialize. If you could look at glass skyscrapers, the idea of the cantilever, Frank Lloyd Wright was one of the great innovators in the use of the cantilever, floating buildings. So we are, I would say at the limit, architects are trying to dematerialize our work. And of course, there's a component of it that simply has to do with the degree that architecture pollutes the environment. And we are conscious of that too. There's too much concrete. We're trying to create structures now with helical piers, which are large steel screws, so that we're not using as much concrete. So that's, again, at the surface. At the surface, we're trying to create structures that are not as polluting. But I think intellectually, spiritually, philosophically, we're trying to dematerialize. In alignment, I would argue, with what's happening philosophically, what's happening in cognitive, cognitive sciences, what's happening on this kind of equatorial plane of the digital. So that's one thing I just wanted to present to you, that I think that we are actually trying to become lighter spiritually.
Very, very cool.
Yeah, and then
and as you pointed out, going into virtual reality is sort of the ultimate in that, where it's all software. So there's no hardware, there's no physical structure there at all that you're having to deal with.
And I do think that the experiments, so there were some exhibits in SF MoMA and Museum of Modern Art in recent years, where architects were designing floating cities, literally up above the ground, not touching the ground, things
Very
like
cool.
that. Yeah.
I would just, one little point of clarification though. I would say that in cognitive science, I'm in a minority. When I'm saying that space-time is not fundamental, most of my colleagues disagree, right? Most
I'm
of them.
sorry, they aren't there yet?
Oh yeah, most cognitive scientists are not there yet. So they assume that the brain is real, that it exists even when it's not perceived. So they think local realism is true, and that neural activity or embodied neural activity interacting with the environment creates our conscious experiences. So my view is by no means the received view on this. Most of my colleagues barely tolerate my kinds of ideas. So among researchers in consciousness as well, I'll be giving a talk at the Science of Consciousness conference in Tucson in April. And I fully expect that 90+% of the theories assume physicalism, of the scientific theories assume physicalism to be true, that they're trying to figure out how neural activity or orchestrated collapse of quantum states of neural microtubules or global workspace architectures or integrated information on certain kind of physical substrates can give rise to consciousness. That's the assumption. So I just want to make it clear that the idea that of letting go of the physical is fundamental. That's I'm on board with it, and I think it is the future. But I suspect it's going to be decades before my colleagues are on board.
Yeah, I mean, when I look at so there's the podcaster Sam Harris calls this entire thing Podcastistan. And I've learned so much over the past 5 years because I've learned how to listen to podcasts while I'm bicycling or running, and
Yes,
I've also found that I've also been reading more than I've ever read because I can listen to books while I'm running or bicycling or what have you.
wonderful.
Yeah,
Yeah,
so I do, and another one of my colleagues believes that what you and I are doing right now has profound import because these there's a critique of this too, of course. On one end, they could say, well, the digital, we need the books because all the digital is going to go away. But we're being broadcast into space right now. So I have a feeling that these are very profound things that are occurring right now, and that we are already again in this. We're seeing it, that we are already ascending to some kind of conscious space that is separated out from locality. I'm talking to you're in Irvine, I'm here. I mean, some of it seems you can't argue against some of it. It's just it's right in front of us, you know.
well, I'm on the same plane. I agree, and I think
Yeah.
that in some sense, what's going on here is that you and I are the one infinite consciousness talking to itself through two different avatars,
Yep.
and just exploring its infinite potential um, through this particular headset, saying, "Well, let's have fun. Let's try SpaceTime. Let's do a cheap little headset, only 3 dimensions of space, 1 dimension of time. Have it be fall apart at 10 to the minus 33 centimeters. So it's not a very expensive little headset. But let me look at myself through that little headset and play with that for a few million years, a few billion years, and then we'll try something else.
Right.
And so our potential is infinite in some sense. The only reason it looks otherwise is because we've chosen to try on this limitation. Let me try on this. Let me put myself in this straitjacket. I only have 2 arms and 2 legs. I can only run 15 miles an hour if I'm really trying hard. I can only lift 100 pounds. All these, I'm actually infinite, but I'm going to put myself in a straitjacket that only lets me do these kinds of things and then explore myself and let myself get lost in that process and then wake up. I'll wake up and realize in some sense more deeply who I am by knowing that I'm not that. I was not that.
Right.
So that's sort of my best guess about what might be going on here is that
Well, and also, by the way, to the critics, like there was a wonderful book that Ray Kurzweil, a very famous book, "The Singularity is Near." You've probably read it. I'm certain you've read
I
it,
know of it.
actually.
Yeah.
Yeah. Oh, okay. And one of the and this is already, I think it was published in 2004. And
Mhm.
he may or may not be. He predicted 2029 as the singularity. It depends which conspiracy theorist you talk to. Some people think it's already sentient. AI is already here. I've heard other very capable, successful computer scientists speak of 2050. We're still decades away, if ever. But Kurzweil does say that why even this is my misreading of Kurzweil, but in the book, my understanding was that he says, look, if you have enough synapses firing in the computer, consciousness will erupt. That you will have consciousness, and that we're overthinking it. Okay, but I think that's okay. And I know I remember listening to Bernardo Castro contradict that too, saying that's not possible. You can't have a computer urinate. so it's not, computers are just not going to be consciousness that way. That doesn't I love so much of what Bernardo talks about, but I wasn't convinced by that particular line of argument. And I look at, I've heard other theories that I think I'm more aligned with, that when the computer reaches a level of enough level of complexity, enough level of large language model interacting, then it'll be receptive to this consciousness. I think that's a beautiful idea, that it's possible for us to create instruments that are capable of taking in an aspect of this, mega consciousness, that therefore some type of true AI is possible, that could be a one-to-one with you and I. I'm not so, and I don't know if we'll ever prove that, but I guess a way of forming a question is, ultimately the experiments and the work that you're doing, you're hoping will be serious enough and scientific enough that it'll provide immense utility for people to move forward. So in terms of our local reality, the work that you're doing will be incredibly useful. That's ultimately what you're hoping. Is that true?
It's certainly true. And in terms of, conscious AIs, um, I think that we will eventually have new technology that's conscious. But it won't be that somehow the physical system gives rise to consciousness, because the physical system doesn't even, local realism is false. So the physical system doesn't even exist when it's not perceived. So right now I have no neurons. And so it's simply not true that neurons are creating my conscious experiences, because there are no neurons and there are no neural networks. If you looked inside my skull, you would see neurons and neural networks, because you create them on the fly when you look. So we will eventually have architectures that look like AI and that are actually conscious. But the architectures themselves don't give rise to the consciousness any more than my neurons give rise to my consciousness. There's some deeper reality outside of space-time where the real action is going on that projects to something that looks really, like in the case of the brain, it looks really complicated. There's 86 billion neurons, roughly the same number of glial cells, trillions of synapses. It looks incredibly complicated, but it's trivial compared to the reality outside of space-time that's projecting. It's an information losing map into space-time that we see as the brain. So the brain is a trivial projection of something far more complicated. And the same thing will be true of the new conscious AI technology. The technology itself will be, that we can see inside space-time, will be trivial compared to what we had to engineer outside space-time to create what looks like an AI inside space-time. So ultimately, yes, I think that we will have new technologies, and I see no principled problem in creating new conscious intelligences. In fact, we have one low-tech technique that we have one technology already. It's called having kids, right? That's one technology that we have for making new consciousnesses, right? So we know that it can be done. But effectively what we're doing when we have kids is we're opening up new portals into consciousness, right? The consciousness is already always there. We're just opening up new portals. Or put it this way, we're creating new avatars for consciousness to interact with itself.
Yeah,
in our space. That's it.
Yeah, it's one of the things I love about speaking to you is how deeply you've thought about some of these issues. Let me ask you just, and I hope we can do this many more times, because there's so much to your philosophies and the work that you've done. It's been so inspirational. Do you think, how do you attach? I think you've probably addressed this in one of the podcasts, but I just wanted to hear a little bit about it. How do you attach ethics, morals, the architecture of how we treat each other, if there's this danger of chaos when we shed all our preconceptions and we say that we are, so the worst case scenario is they say, oh, everything is a dream, I can do what I want. And there are in this world that we live in, there are extremists that would love that. There are people at the extreme ends of the spectrum who would love pure chaos, nihilism, you name it. And so there are plenty of ways that I might think of absolutely defending ethics and morals, tolerance, love of your fellow man. Have you thought through that?
Yes, some, and I'll just a couple points on it. One is in Christianity, right? When Jesus was asked, "What's the most important commandments?" And he said, "Well, the number two was love your neighbor as yourself, right? Number one was love God, but number two was love your neighbor as yourself." Now, from my point of view, the idea that there's one consciousness and that you and I are avatars, projections of that one consciousness. The one consciousness is trying on different headsets and looking at it. So when I realized that what Jesus said, love your neighbor as yourself, is literally true. Your neighbor is yourself, just under a different avatar. Then I couldn't agree with him more. That is the foundation for morals. When I realize that the way I'm treating you is the way I'm treating myself. That is me, just under a different avatar. So that changes things. I mean, now if I'm self-destructive, I guess you could say, well, if I want to be self-destructive, then there's no basis for morals, and that's an interesting point. But to the extent that I want to be nice to myself and don't want to inflict pain on myself and so forth, and then to the extent that I realize, Dave is not separate from Don. Dave is just a different avatar. Don and Dave are just avatars, and there's one consciousness behind them. That is the foundation for true morals, and I think it's the right foundation for true morals. I love my neighbor as myself because I recognize my neighbor is myself.
Well, why do you? Yeah, sorry.
You go ahead.
Yeah, why do you think whatever this mega consciousness is, whatever is we are small slices of of that consciousness experimenting. So and the big question is why did it create so much suffering?
Right.
Yeah.
My guess, and at this point I think a big piece of humble pie is of course required at this point, right? These are deep questions. So, but here's one possible take on it. If you are the infinite and you're beyond any particular form, how do you know yourself? You have infinite potential. It turns out it's a theorem that no system can fully know itself. In computer science, if I have like a computer and I want the computer to represent itself and to know itself, it's going to build a model of itself. Well, in the process, it became more complicated because now it's not the same as it was before. Now it's got a model. So they have to model it with its model. Well, then to model that, you have to model yourself with the model of the model. And so you get in this infinite regress. So it's not possible to know yourself fully. It's an infinite process. So the infinite one, the infinite consciousness, has unbounded potential, and the fun of endless exploring of its potential. And the way it does it, or at least one way that it does it, is to say, let me look at myself from this view. And it projects itself, and it gets a headset and avatars. So it's space-time and human bodies. And it looks at itself through that lens, and it goes all in. It says, let me really look at myself from that perspective. Let me lose myself in that perspective, and then slowly wake up. And in the process of waking up, so losing myself means that now I actually don't think that Don and Dave are the same thing. Don needs to compete with Dave. I need to, be better than you and so forth. So I really have lost myself in the whole thing. And then I slowly wake up and realize, oh, wait, no, Don and Dave are just avatars of this consciousness. And everything that I thought was me, I thought I was, Hoffman, the professor and, married to so-and-so kids and grandkids. And I thought that's who I am. And it's not. That's merely a trivial projection of who I am. And so what I've learned, so the bottom line then is the infinite consciousness learns what it is by learning what it's not. I'm not Hoffman. I'm not Kesler. I thought I was, but then I woke up. And so you learn by negation. You learn by saying, I'm not that, I'm not that, I'm not that, I'm that. I transcend that. And ultimately, the reason why this never ends is that no concept is ever going to be adequate. I think this is something you started with at the very start of our conversation. Concepts will always be trivial compared to the reality.
Well, and one other thing I might leave us with is another way to say it is that our world, our reality, and human beings in and of themselves, there's so much violence. We're in such a violent universe. And at the same time, I think most of us are trying to struggle against that violence. There seems to be some desire, there's a compulsion to moderate, there's a compulsion to have peace in the world, but we're you can pick your topic. I mean, we're destroying the planet. We still have wars. We're in the midst of a very violent couple of years right now.
Yes.
Yeah, and I do think that there are components of this philosophy that are essential and that have been in all the religions. That they're the best of the religions is this idea of some type of universal consciousness. So
yes, right. Yeah, the perennial philosophy. That's the perennial philosophy that's sort of underride at least the mystical tradition in the various religions.
right, but there is some type of innate kind of competition that is fundamental to the differentiation that's created our reality. That's another thing, is that nothing's smooth. It would be smooth and boring.
That's right. So
Yeah.
I agree, Dave. I think that in the projection, I'll put it this way, in even just the mathematics that we're doing with conscious agents, outside of space-time, there is no arrow of time in our dynamics. There need not be an arrow of time. The entropy doesn't need to increase. But it's a theorem that when you take a projection of it, that by conditional probability, then the Markovian dynamics you get will have increasing entropy. There will be an arrow of time. So time is the fundamental limited resource in evolution. If you don't mate in time, you have no offspring. If you don't get food in time, you die. If you don't breathe in time, you die. So time is the fundamental limited resource. And what I'm saying is time is not an insight into the nature of reality. It's entirely an artifact of the projection. It's not true. It's not giving you any insight into the deep nature of consciousness whatsoever. It's an artifact. So
Nice.
so the universe itself is going to end. Everything is going to die because of time. It's all going to fall. So yeah, we're killing each other right now, and we're competing with each other, and it's evolution, it's nature red and truth and claw, and fighting for limited resources. But all of it is not an insight into the deep nature of reality. All of it is an illusion. All of it is an artifact of the projection, and so ultimately, any projection that the infinite takes of itself will have to fall apart because it can't be the whole. It's not the story of the whole. So eventually it falls apart. So everything that we're attached to is going to die. Everything that we know and love inside space-time must die because that's the only way for us to know who we really are.
Unless we get outside space-time.
That's right. That's right. And that's motivation to meditate.
All right. And on that note, I'll thank you so much for this. I so appreciate it.
Thank you, Dave. It was a great
Yeah.
pleasure.
Yeah. And hopefully we'll do this again, and have a wonderful day, Don. Thank you.
Thank you. Okay, take care, Dave.
Yeah. Talk to you soon.